Yeah. Hi, everyone. I'm very pleased to be here today. Thank you, everyone, for this opportunity to show a little bit what we are doing here in Ballard. I will just introduce myself briefly. My name is Adnane el Idrissi Ammari. It's a very long name, as you can see. I'm originally Moroccan, and I'm living here in Viborg in Denmark, and I'm working here as an academy engineer at Ballard Europe in the customer care department. Well, my academical background is that I'm having different things. I started in business administration and marketing, business development, logistics, supply chain, and then I have studied again marine engineering and automotive technology. My professional experience, working 12 years in the automotive industry, of course, with marketing, end up like in sales and business development and IT project management. And then lately, I end up I went into like few years of entrepreneurship, self-employed, having my own company and associate professor in one of the Danish academies here in Denmark, and developing a program, actually, academic program here. That's how I'm in Ballard. Actually, working. My mission is to develop the FC Wave product, which is a flagship product training, and developing the Ballard Academy. So, sorry. Oh, that's cool. That's the way there. Yeah. So in my presentation, I'm going to take you like briefly to the fuel cell system, then the fuel cell system like technology and development, of course, in Ballard Power System, the story behind. We are going to talk about HySeas as Ballard Power System, how we are implementing it, health and safety. So I'm going to take it like first about how we are taking care about the environment. And then from there, we go into health and safety. And then we are going into the HySeas in our own systems, actually. And we are going to take as a study case or the FC Wave. And then we go for a small test of our sensors and smoke detectors, and how we are handling actually hydrogen leak as a procedure. Of course, we are in full development, so we are going to work in share with you on how we are prioritizing safety in our products and how we are implementing this in our communications as a solution to our customers, and what we are recommending to our customers. Ready? So, start moving. Try. That's present. So if we are saying like about hydrogen is a gas, that it has a long story with oxygen, isn't it? And actually, we all know that it's a very lightest element. It's one of the most lightest actually molecule that we are having in this planet. It's odorless, it's tasteless, colorless, not toxic, and highly combustible. So actually, if we want to go back to the molecule, actually, this is very important to know. We're having the proton that they are very positive, and we're having the electrons. And with the air, if we try to ignite it, there is what I'm calling always this love story between hydrogen and oxygen, that it can end up just by providing pure water. I'm going to say pure innocent water. And if we take it, so it means that we don't get no CO2 and no toxic gases. From here, the question that we have asked ourselves, how do we use this gas as a source of energy to empower our machines and so on, and how we can use this formula. So we end up having the fuel cell as a solution that we provide the hydrogen and the oxygen to a module, and then we can get the water, but of course we can get electricity from it and heat. So here, if I'm going to say, to show you a little bit how this is happening. So if I'm going to explain here and in the video, so normally what we are having is like we are providing the hydrogen and into an anode, and then we are having actually the membrane in the middle, which is like membrane is a proton exchange membrane. And of course, there is a movement from the hydrogen, from the electrons to the protons through the membranes. And we have here on the top, can I just like this? We are here on the top, actually what we are, the electrons moving, and that's what is creating an electrical circuit. So from there, what we are generating heat and of course water and electricity. This membrane is exactly the product that we are having in Ballard. So the company is actually one of the leading company in the proton exchange membrane, the PEM. And from there, from this idea, they have developed this product that they can come with first by actually having a lot of like units and a cells component, then developing a fuel cell stack, and then making it into a balance and into a model and a system. If we can say take from this idea, as we said, like it's from a formula to what we are having right now is like we are implementing the technology everywhere. And that's where we can have like from in the automotive, from buses, trucks, cars, and we are having it as well as a backup for the stationary systems and so on. Today, we are having actually this technology everywhere, and I think I went a little bit out of the scope of the safety, but what I want to show here is that actually safety is everywhere. Because if we are talking in this business, if we are talking about hydrogen, if we are talking about a system, if we're talking about a product that is actually implemented in many industries, so Ballard is present, and therefore we are actually highly implementing safety in our protocols. For the environment, very important point here I'd like to have. I don't know what happened there. Yeah. So we are using in our product what is like the coolant, the ethylene glycol, which is like plus is the composition of our coolant plus the DI filter. The DI water. This is an organic component. That's, as you can see, the formula over there. It's very important to know that this product is used for a purpose. So the DI is like because it's like it helps to keep our application, from freezing in the winter, and actually as well it reduces the overheat. When we talked before about the fuel cell system, we said that it's generating heat. So of course we are using this component, to protect it as well as to reduce the heat that we are having. And for DHS, it's very important to know because that's how it is affecting lately, if we can say in the year, or is like it has designed as a hazardous air pollutant, as well as it can be in the water, as well as it can be in the food. So I don't advise anyone to drink it because it can damage actually the liver, the kidneys, and the brain. Half liter of that is dangerous. So, of course, as a component, we are aware of that. As everyone else, we are using like the protection, like the personal protections that the people like in our sites as well as our customers, they have to use. Now we talk about hydrogen. At Ballard, we are in the hydrogen valley right now. So we are asking everyone actually in the company, we have a hydrogen alarms, and we are asking everyone actually to go off. Every time we are here. So it's as we said, is like a high combustible. So flammability ranges between 4 to 75%, as we said. And of course, and the very low ignition energy at 25%. From here, I'm going to take it to in our products. So safety is very important in our products. That's something super important, and this is how we communicate and we keep our communication very close to our customers. If I will say how we do that is by actually having trained, giving them very good training, and our training is very focused on safety. Of course, understanding of the logic, understanding of the product, of everything behind, but safety is very important in all the process. So we are releasing to them very carefully, like very, very good documentation. So they have actually, beside this, in our training, we try actually to give them how a good information to how find the information in the documentation that we are providing them. And we can actually make them aware of the safety, how important actually to care about safety before touching the motors. This is actually how we do it. We are having applications engineering, we are having engineering services, and after-sales department that is taking care of that, training and marketing support. As we provide safety training, we provide as well high quality features, I would say, that they are actually implemented or integrated in our motors. And from there, we are having, from the example here that I'm showing, we are having the ground fault monitor, the ventilation, the process, the smoke detector, the high voltage output, like for example, fuel cell pressures, and so on. But beside this, we are actually showing them how they can, how these features or items can be used, and how they are integrated, and how they can help them actually how they can understand actually the use of them. Well, we are providing 3 levels of safety of training. The tier 1, which is a basic level. The second, which is a tier 2, which is much more preventive and maintenance. And the third one is a troubleshooting that's much more like related and collecting the data. And every time is very, very close to safety. Of course, the first thing we do is like about the PPE and how the personal safety can be involved before touching the model. We do like that to them to remember that their surface or moving parts like electrical can be inside the system before, during, and after the operation. So they have to be aware of that and to identify the hazards in the system. This is a process that I'm going to talk about it. So this is a kind of a model of the training that we gave them before. And for example, and why? So it's one of the tasks that we give on the preventive maintenance is to check. So they have to make all this kind of check-in list, to follow that. And of course, for example, why? For example, in the coolant, if we say the conductivity, if we are talking about it, it's very important to check that. And I've been just like in Netherlands before, and they asked why. Why we have to check this conductivity? Because actually, if we are having a high level of conductivity in a bus, the system can, the people, they can feel kind of electricity, current in the chassis. So that's why they have actually, every time they are doing the preventive maintenance, they have to actually to check the coolant conductivity. And we give them real examples. So this is like a checklist that they can do, for example, from the smoke detector to the air compressor and filter, the ground fault monitor, and so on, when, how many hours, and so on. And this is exactly how the system is. So if you are having, for example, we give hydrogen, oxygen, and coolant, and then we generate electricity, heat, and work. And of course, we are communicating, as you can see there, we are communicating constantly with our customers to know exactly and to help them, as well as to understand what's going on, in the system, in the model. So if I will say, this is the main hazards that we can have. And that's where we are having high voltage, because present on the stack for some time after the shutdown, this is very important to know. Even if we will shut down the system, there is always a risk of having a high voltage. Second, high temperature is that it can reach 150 degrees Celsius. We are having high pressure. We are having hydrogen leaks, as we talked, because it's a molecule. It's very, sorry.
Where do you have that high temperature? Just
yeah.
curiosity.
Why?
where and which parts of that height?
Yeah. Actually, it's in the fuel. You can find it actually in the fuel stack. You know, that's where we are having in the stack.
Okay.
That's where actually the chemical conversion is happening, right?
But the temperature is around 70 BC.
It can, yeah, and that's where we have the coolant.
Okay.
That is coming always. That's the purpose. That's the purpose of the coolant.
Okay.
And when we are having a coolant like that, this is why we have in safety we have to handle it. Actually. You know, because like sometimes when we are having a draining procedure, you know, it's not just coming and through the coolant, you know, like in the corner, right? So it's like there is a whole protocol that we are trying to constantly communicate to our customer about it, right? And purpose. And then we are having the chemical, as we said, like ethylene glycol, that's what we talked about it. And we have the mechanical, which is like the many heavy parts. And here I'm going to show a little bit. Yeah, I'm going to show a little bit how we do it. So we are actually warning against the hazard of unsafe practices that can, of course, you know, I'm going to say the results injuries or death. We are having also against the hazardous or unsafe practices that it can get a minor, you know, injuries in the product or property damage. And of course, we have the high voltage that we have to be careful with. Every time we explain and we show them actually a pre-service inspection. Like before you open, there is a procedure that they have to follow, you know, to shut down the system. And this procedure, it's helping us actually to, as I said, like because in the high voltage, even though if the system is closed, but there is always a risk to have electricity. Yes, no problem. Yeah, please.
I have a couple of questions. The high voltage, when you shut down the fuel cell, you will have, was it the 500, 550 voltage possibly on the stack, right?
To 800, because we are talking about, we are talking about that. Yeah.
But on the high voltage side, how do you drain it when you shut it down?
Yeah, I'm gonna come to it. Yeah, there is a whole.
There's a whole chapter, I guess.
Yeah, there is a whole chapter. Yeah. And now I'm gonna just like be much more efficient because I really need it.
Yes.
I really need this one. So before servicing, as you can see here, we have to do this inspection, and there's like included like a visual inspection, and of course proper system grounding. This is like one of the things, and the component damage. Like if there is anything before, they have to know that, and they have to, you know, to be aware of it before touching.
Peter has a question.
Yes.
Peter, go ahead.
Yeah, thank you for that. If it comes later, then let me know. But I was just curious about, now we're talking about specifically with a maritime product and the situation that we would have like very remote operations. My question is about, you showed a bit about this training you already, an inspection guidelines you already developed for like automotive. How much have you developed that for maritime specific as well? And what are your expectations of how much the crew themselves would take care of all of this you're explaining now?
Well, we are in the process of developing that. You know, actually, we are developing this training, and actually, I'm just after this one, I'm gonna just like keep showing some of it, you know, to you all, and we are expecting to be ready for the tier 1 and the tier 2 in September this year.
Okay, and when you are that, what do you is it the expectation that the crew themselves would be competent in these things, or should it be specialists for like?
So I guess, I think how much maintenance do you expect the crew? How much maintenance and troubleshooting do you expect the crew to do, and how much do they need to call back to headquarters for help?
Yeah. Well, as I explained before, like what we have it like shortly is that we are having the tier 1 and the tier 2, you know, and the tier 3. The tier 3 is troubleshooting, and that's something that we are expecting. It's like as soon as, but we are working. Actually, our team is working hard, like to provide this training. If I'm talking about the training, so right now what we are doing actually in the tier 2, We are already developed the tier 1, and we are almost close to this summer. We are working on the tier 2, and that's exactly what we said. Like we are going to meet our deadline is the first week of September on tier 2. Yeah. So I'm just gonna. This is something that one of the things that we have like about safety, like solutions, as we said, is like in mechanical. There we are having like maybe this is for Peter to see as well. We are having like, for example, changing humidifier. Our technical force, they have shown, or like they came to us, we're saying that is a very heavy component. So we have developed actually a special table that it can enable like the team, or like the technical the technicians actually to move this humidifier in a very safe way, or safer way. So that's one of the second things, high voltage. We are here.
So, sorry, would you expect the crew to replace the humidifier, or would you call a technician from Ballard to do that?
A technician from Ballard for now.
Okay.
For now, but if they are actually certificate for tier 2, so then of course the humidifier can be like, if it's like in the contract, then they can. And our goal is actually to train the trainers, so we can actually, we're working on that, so they can actually as well,
So ultimately with tier 2 and tier 3, you almost want to enable the crew to be able to do quite a lot of maintenance, and
I think
would
it's
that be
standard
fair?
maintenance protocol. We'd love to train the
Yeah.
crews on the ships to be able to handle it.
Okay,
It's the bigger stuff
okay,
that we're gonna ask them to just return the fuel cell as it is in situ, and then and bring it here, and then we'll do all the big stuff, like the giant
Yeah.
services.
okay, thank you.
So for the high voltage, our system is having like 3 levels of severity. So, and these levels, they are changing from 1 and to the second. So like if we say there is a warning in level 1, there is an alarm in level 2. So the integrator, if we say like, for example, in the ship, he will receive that. So he knows exactly, I'm going to explain later how things are and which level he is. And from there, like in the silver, like if the level 3, there is a completely shutdown. So if we say about the high voltage, I'm trying to just like to get it like very, very fast, is like we explain a little bit how it's dangerous, and how it can give, in each bar, increasing from the probability of death, so they can be aware of the danger, and of the hazards as well of the high voltage. And if I'm talking about that, we are talking like from a range of 24 to 800. This is the maximum that we are pushing, but I know that it's like above 500. This is like what we have. And of course, there is an external, like as we do, like the power supply for the troubleshooting might have required. And of course, we do like the model running without a cover, that also like can be, so we show all this kind of situations when a problem or, an accident can happen. Well, for the high voltage, what we are doing is like we are trying in our training to say before they have to check like the performance before working on the fuel cell, and to ensure, like, for example, measure the voltage across the stack, the high, if we say like the high voltage positive and high voltage negative, and 5 volts. This is like the first one. But we are actually, lately, our team like announced that we are going also to 10 volts as a possibility. So there is as well the measure the voltage across the stack as well, like, and the module chassis, like if we would say like, or, like the ground bounding point of 5 or to 10. And we have as well, like as well to, from the stack high voltage negative, and the module chassis as well from, or like the ground bounded point of 5 to 10. That's what we want.
Yes, I have a
That's
follow-up.
what I want. Yeah.
I have a follow-up question.
Yes. Yes.
There's a reason why I asked for this voltage is if the fuel cell stops, you have to drain this voltage. But in an operational state, if you have an unexpected stop of the fuel cell or a power source, you will have a recovery time to restart it.
Yeah.
So the class rules as far as I know, it's approximately 90 seconds for an emergency generator to kick in. If you don't have emergency generator, on some designs, there's no emergency generator, how fast does it drain before you can restart it? That's actually a safety related question. I'm trying to make it a safety related question.
Yeah.
Because you need power, right?
Absolutely.
And of course you have
Absolutely,
redundancy,
absolutely.
but at some point you need to restart it. And for the 200 kilowatt module, it's the FC wave, right?
Yeah.
What's the expected time for a full, if you run on 100% load and it stops, when can you restart it?
To be honest with you, I don't know the answer, the exact answer to tell you like about it. But that's something that I would be very happy to answer to it.
It's also a design issue, right?
Yeah, it's because we are having a whole design center is like behind, about to give you the right information.
If you're running a split switchboard with a redundant switchboard, you'll have a secondary side you might be able to start up, right?
Yeah.
But if it's segregated on one switchboard and you're running full power on everything and one of them shuts down,
Yeah.
you need a recovery for the secondary thruster and
Yeah.
things like that.
Can I get in touch with you? I would love to do that, and then I can,
more operational safety.
Yeah.
And just last one.
Yeah.
It's pretty dormant on the when you're talking about operators doing maintenance and commissioning and or testing and so on. How is your philosophy regarding protecting the fuel cell from unintended use for making it dangerous? You're talking about this training, of course, but are there physical blockings of what the operator can do to protect themselves of unintended use?
The software and hardware is locked.
Uh,
There's the software itself, they won't be able to access the system through software.
Can they
unless they're-
access the door? Can they open the
If
door?
the key is there, but there's a key.
There is a key.
That's
It should
no-
not be
Yeah.
right on top of the cabinet.
So there is a philosophy on protecting, right?
Well, there is like different methods actually to protect it.
Yeah.
So there is a whole protocol, like I said, like there is a key, but before the key there is also the software, and this is exactly, if I will go right, so maybe like this is for you, like it's something that we pass it. For example, is like to use like the PSV, and we are trying to show them that, so that maybe the high temperature, like for example, this is a system that I can go with it, is if the temperature is going like, is the same logic that we said with the separation, so we are having different, and if like the temperature is going like, for example, to 75, so we have like the first, then it's 78, then 72 to 80, etc. So that's the way the software is coming. So we have the engineering interface, that it's actually, and the software is reacting completely to shut down, the system for protection. So,
if you have an external cooling shutdown, so the external cooling for the fuel cells disappears, what is the temperature that you will reach inside?
like,
Even if you have a shutdown at 80 degrees, you will still have some residual heat inside.
Yeah.
What's the maximum?
yeah, but this is like actually, we are having like, if I would say there is like maximum to 150, right?
Okay.
But actually what we are trying, this is what as a component we can find. And actually there is also like what we have like a system with the cooling system that is given like to put the temperature down.
Yeah, but if that's an external system.
Yeah.
But if I have a fault on the external system.
Yeah.
How will your maximum temperature then reach?
Well, the temperature, like the maximum that it can reach, like if I would say from, like as we said, like if we are having the temperature, there is 150.
Okay.
Yeah. But,
So you're saying that if the coolant system fails,
yeah, as
then
well.
you will shut the fuel cell down. There will be some residual heat, and they will creep up.
Yeah.
Yeah.
While there's no cooling, but
For instance, if you're running at the normal temperature, you might run about 74 degrees. And then I have a shutdown on my external cooling system.
Yeah.
Then what could we expect to have inside? That's my question. And then you say 150. Because that will at some point happen, because that's external pumps.
It happened to you before?
Yeah, it can happen. I do, and when it can happen, it will happen.
It sounds like a cause to an effect of
Yes.
shutdown of the effective shutdown
Yeah.
of the fuel cell from
Yeah.
from an integrator,
Yeah.
I think.
There should be a sort of fundamentals. Once the membrane dries out or you've got steam in there, it won't be able to conduct electricity anymore, and that should be a fundamental limit.
Yeah.
So I think the figure of 150 is probably about the worst it could possibly
Because
get.
yeah, this is like the worst that it can happen.
Once all the water is turned to steam, you've got no
Yeah.
conductivity.
Exactly. But what will then happen with the steam pressure inside?
It'll be ventilated
To where?
out the top.
Yeah, the chimney, literally.
Yeah, there you go.
You have expansion tanks on the cooling system, ventilation expansion tanks.
Yeah.
Similar to what we had on HySeas,
Yeah.
right?
Yeah.
So that then it's ventilated on the top,
Yeah.
so it will.
Yeah, you won't get a massive build of pressure.
So basically we do the same with the pressure because I'm just like, now it's like, this is where we go to the hydrogen, you know, like, because actually the pressure is between 3 to 6.5 bars. And I can see myself that I'm with professionals here. So I don't need like to show a little bit, you know, about like things, but I just like say that we are trying, what we try to show to the technicians down there, you know, that how the pressure can actually also like can be a problem and can be dangerous. So if we say about the hydrogen leak, let me just give like, for example, the way how we are trying to do it. We try like actually to explain that it's invisible, that it's high, that the ignition and extremely low, the sensor might fail. And like, for example, the exhaust can get blocked and the dilution T might be blocked. So like this is things that we actually show. And of course, we are having the 3 level of severity. And then here I'm going to go for this sensor, H2 and smoke detector. So this is like, for example, for you to, basically this is the system. And here we are having in the FC wing, we are having, for example, two sensors. We can see like in the ventilation outlet, and we are having a smoke sensor over there. We will do this test like to see, we bring like, for example, hydrogen, and we mix it up, of course, with air, as well as we do some smoke. And this is exactly what we are having. So the reaction of the sensors, how it can be. Like if we are having for between 0.8% in an average time of 10 seconds, it's like going plus minus, you know, 30 to 42 and 50. So the first, this is the severity, you are having the warning 71, 2, and 3. So we are having actually an analog. The first one, it's an analog. And the second one is a digital, as you can see. The analog is like sending actually 3 signals that we can see over there. The digital, the sensor that it's connected that there, we are having either good or no good. So it's like if it's okay or not. So and the system, it can shut down completely. In the engineering interface, this is gonna look like that. So that's where we have done the test, and it can like, and we try actually to show this, all this information and the way how to handle that, you know, to our technicians as soon as we, you know, in our training, of course. In the safety, this is like kind of an example of the check that we are doing with them. How they can, they can lock down, how the system in the engineer interface is reacting. And of course, in the preventive maintenance, we show them, of course, how they can change or they can make some tests to the sensors. A procedure that we follow is the CE, the SIVVI. So every time we are having a leak, because this is like, we try to educate and like because we can see that there is no foolproof like procedure to ensure the safety in the service panel, but like what we try to do is like to educate and to make them aware of the hydrogen potential hazard. So every time what they have to do is to actually, from the sense, use the procedure carefully, isolate. We have to ventilate and as well investigate to make the course. And this is like, based on that, we can actually see how from where like the hazard is happening, how we can do better. So if we say like, to answer like to your question, is like one of the things that are very important is the general safety, it's like actually there is a lockout procedure. Every time that there is there is like level, there is a lockout procedure to follow. And we try to show them like how they can actually proceed, every time that this hazard is happening,
A software lockout, is it?
Yeah. So I'm going to give an example. It's better to give examples like it's. We have yesterday been in Germany, and one of the things is that we went into a preventive maintenance with a company down there, and in the preventive maintenance they have actually to make a for the sensor, the hydrogen sensor. So they have to make, like, for example, they have to make a test. So first is like we had to make the test, and then after making the test, we do like, because they have the smoke detector and they have the hydrogen sensor, as well. So we try to, when they do like to make them aware like how they can do that test and how they can actually, again, unlock the system and how they can actually reprogram the alarm as well. Because that's when they're in the system, they have an alarm. That's we have to redo that. We are developing here the service manual. This is something that we show them how to find the information over it. And basically, we are doing as well the user manual, which is like a small, because we know our technicians, they don't like to read 295 pages. So what we are trying to do is like to do like a kind of very efficient, user-friendly way to find the information. And in this user manuals, every time you open, you find actually in each task how to approach the task in terms of safety, and then how to approach it like technically. So this is, and right now we are working on making it much more like efficient in our communication. So by having a QR code, so the technician can just find this, and then it will find the information very, very well organized. The tool that we recommend is like from the lifting, from handling tools, actually to use a handheld like flammable gas detector is very important to have, always with them digital multimeter, conductive meter, bonding like check meter, and test smoke. So all this list, they can have it like, and we recommend it as a tool in their preventive maintenance. Thank you very much. I hope that I didn't take that much time.
Perfect timing.
Great.
It's
Perfect,
great. Yeah, no, thank you very much. Peter, you have a question. Go ahead.
Yeah, thank you. Yeah, I was just curious about specifically for the marine unit, the FCVA you have developed. Could you elaborate a bit on like what kind of like fundamental additional safety measures you kind of have to build in compared to the more standardized automotive module? I mean, how much it differs and how it differs as a maritime unit. If I don't know if the question makes sense there, but I mean, it's got like just fun.
Yeah, it makes sense.
It makes sense, but I'm afraid we can't really go into the details of that quite yet. We're just wrapping up some testing with DNV at the moment. We have our type approval, but I'm not sure if we're allowed to really elaborate on all those details quite at the moment.
Could you elaborate on like how much like would it be like without saying anything about pricing development and running hours development, but would it still be like some way a direct correlation with what we see from like pricing in automotive, but just on a would it follow the same logic or?
Well, our design center is working very hard. Like we have like people from, and the company is hiring a lot of people like from the marine industry. And the purpose of it is actually to get the experience of those people and to implementing it as much as they can, you know, in a very proper manner that it's aligned actually to the product. So what I can say is that it won't be like 100% automotive. It will be 100, like I'm gonna say, like a very, very aligned with the marine industry.
Okay.
There are
Requirement.
the testing suite that was put forth by the DMV when we were going through the type approval process is extensive. Marine safety checks are far more intense than anything automotive on a road or on a bus, et cetera. So there was a good, I would say, 12 to 18 months of concentrated safety work that we were testing to certain points, tilt tests, heat tests, explosion tests, gas tight, pressure tests, blah, blah, blah. The list continues on and on, but I would love to be more detailed if I could, but I just don't think I'm authorized to do it at this point.
Okay. Oh, perfect. Okay, thanks.
Peter, I think that when they get further down the line, I mean, I think the idea was always that we would get Ballard to present to the center, and then maybe there they can talk a little bit more. And if you send the questions beforehand, that's something they can consider more carefully.
Yeah,
So,
100%.
Yeah. Maxim.
Yeah, thank you. I have actually two questions. One on the hydrogen sensor and smoke detector test. Is it an internal test or is it something that you do as a part of maintenance?
Well, of course, it's a part of the preventive maintenance is actually to test the hydrogen, like the sensors. It's very important actually to keep testing them. So we are sure that actually the safety is implemented, you know, in the module.
Yeah, so just to make it clear, so there is no internal self-test of the stack of those systems.
The software continually self-tests.
Yeah.
Okay.
But
Okay,
that's an automated process that it goes that just runs in the background.
Okay, thank you. And the second question, could you please give a bit more details on the ventilation of the fuel cell container? It looks like the air intake and outlet is practically very close to each other. Is that the case or not?
Could you repeat that one more time? I didn't catch that.
Yeah, the ventilation of the container where the fuel cell is, the air intake and the outlet, are they located practically in the same area?
Are we talking about the FC wave or are we talking about the containers that we were talking about in the presentation before?
FC wave.
In the FC wave, the air intake, the process air intake is the slats on the doors. And then the ventilation is at the top.
Okay, thank you. Yeah.
One question also regarding when you do the sensor test, the hydrogen sensor test, is there on the fuel cell a kind of a test mode?
Yes.
If I activate it, it will not shut down
If you're running it, there's going to be a test mode
on the fuel
protocol in the controls. Okay. Yes.
So when they use on the ship, they will do a kind of a routine maintenance, checking all the sensors once a year or once a month or something like that. And they don't want to have the fuel cells shutting down.
Well, if you're running a test, you would logically take it offline.
You need to put your fuel cells in a kind of a test mode.
But we are hiding also, like we are having like the sensor, like the anti-sensors, you know, like so that this is every time they open, so we have actually to try to see if there is any leak, you know.
Yeah.
Yeah.
But do you have a room sensor where the fuel cells?
Yeah, there is this one that it's like normally is programmed, it's flat, you know, like that you are having to do it like, you know, into a.
There are limits to automating to automating your sensor checking. If you think about it, if you want to know if the sensor's picking up smoke or seeing a flame, you have to let it see smoke. Or
Yes,
flame. So
exactly.
you've got to interfere
Yeah.
manually to do that. So
Yeah,
and you can check through software routines that they're all right, but to actually do a full test, you need to go in and
yeah, you need to check the
give them,
sensor.
give them
Yeah, then you'd have to take it
stimulus.
offline. You wouldn't be able to run the fuel cell and test the sensors at the same time.
But if you come back to your earlier question where you were asking about single points of failure in effect, and this is kind of your thinking, you vessel have a lot of redundancy in terms of power delivery capability. So you can take one bank out, test offline as Chris says, and test the sensors while the others moving you along.
Yeah, but when I have to take that into mind when I do a design of the ship,
Yes.
because if I put all
Yes.
the fuel cells in one room, and I test that sensor, and all the fuel cells are my main power source, then I have a problem.
That's what they're buying.
Yeah, exactly.
Yes.
But I also need to take into consideration when I do the test, I'll go down to 50% power on the ship if the fuel cells in the room will shut down.
Yes.
So currently, you're gonna always be running a hybrid system, so there'll be batteries and fuel cells.
Yes.
So you just turn the fuel cells and run on battery backup.
There's an interesting issue actually about having to run the separated banks where you get to smaller vessels. You may only have one plant room, larger ones certainly. One can have that redundancy.
Yeah, but if
That's the situation you have at the moment. If you only have one diesel engine, it will only be in, you might have two in the same chamber anyway. For smaller vessels, so there's
Yeah,
a sort
but,
of scaling effect.
if I have a diesel generator, it will not be shutting down if I do a fire detection test. It will.
Yeah, it's important to think through these because these are threat management issues.
I'm just thinking if it's possible to do a kind of a test mode on your system saying, okay, now I'm activating a test on my sensors, then I can override your safety.
You shut down.
Yeah.
It's just a suggestion.
No, it's a good question. Yeah.
Just a side view there on HySeas project. The way we did that, we can run the fuel cell, but we can from a system integrator we can it's called inhibit the gas sensor, test the sensor.
Yeah.
That's not, then you kind of take it out of the equation to shut down the fuel cell if the fuel cell is running. And that's a time. The inhibit is a class rule, of course. It's inhibited for only a limited amount of time to be able to actually test the sensor itself. But it's not completely fair to compare with a generator because the fuel cell you can run on low idle state, not low state, and you can actually shut it down with a gas sensor. And as we showed at the hierarchy, you kind of can segregate the part where you want to test it. So, but it's a design issue.